The next video in our series of how to find the derivative of basically everything in Calculus AB deals with inverse trigonometric functions. Well, if you haven't watched the chain rule, if you haven't watched implicit differentiation, pause this video, go back and watch. You're not going to understand what we're doing, or no, you won't understand. You might still be able to do this stuff, but hopefully your goal is to pass the AP test. So all we're doing today is finding the derivative of each of the 6 primary inverse trigonometric functions, and we have to do that using implicit differentiation. Okay, let's make sure we understand this equation. Y is the inverse sine of x. You might be familiar with another notation. You also might see, oh my gosh, y is equal to arc sine of x. These two things mean the same thing. Let's talk about another function, y equals sine of x. A lot of people use this function but aren't super clear on its meaning. And what they're not clear about usually is what the x, what the y are. So let's say we have some triangle, because usually trigonometry deals with triangles. Where is x? Well, sine takes an input that's an angle and has an output that's a ratio of sides. Okay? So sine of this angle x is actually apparently y over 1. You've probably memorized it sometime that sine is the ratio to the side opposite in a triangle divided by the length of the hypotenuse. Okay? So this can't be the case. I wish I had done this using not y and not x. That's super easy to change. So let's just say f is equal to sine of t. Okay? Because now we can say this angle is t, and this ratio is f over 1. The sine gives an output, that's a ratio of sides. Sine has an input, that's an angle. Inverse sine, this is shocking, is the inverse function of sine, meaning all of the xy coordinates in regular sine have been flipped to yx or something like that in inverse sine, which means inverse sine has a ratio of sides, has its input, and has an output, and that's an angle. Okay. Hopefully that is a quick review of stuff you already knew or forgot. Okay. Now, if you're watching this video, you want to know how to find the derivative of inverse sine. If you just wanted the answer, you could look that up almost anywhere on the internet. Try Googling. However, your job is much harder than that. You need to understand. I'm sure you can tell by now I'm recording these videos during the middle of the school day, and we have bells about every hour. If this goes long enough, you might hear another one in about 6 minutes. Let's see. So I know how to take the derivative of y, that's dy dx. I know how to take the derivative of sine of x, but this isn't sine of x. So, like we do a lot, we're going to rearrange to make our lives easier. So we are going to take sine of both sides of this equation. We do have an equation. We can do whatever we want. Sine of y is just sine of y. What's sine of inverse sine of x? Turns out that's x. You don't have to worry about a domain restriction or anything because this x is just some number between -1 and 1. Those are all the ratios for sine. Think about the outputs on the sine graph, only from -1 to 1. Okay, so what do we do now? Well, we have things we can take the derivative of with respect to x. So we'll start with easy. The derivative of x is 1. the left-hand side isn't bad either. What's the derivative of sine? Cosine. Of what? Whatever you had. In this case, y. And we have to apply the chain rule. The derivative of y multiplied to the end, we're going to use y prime, not dy dx. Look up top. Okay, so I found y prime. Y prime is 1 over cosine of y. That's not cosy, it's cosine of y. Put in parentheses. I don't know, whatever you want. Now, this isn't wrong, 1 over cosine of y for the derivative of inverse sine of x. But it's likely the inputs I'm going to be given are x's, not y's. So I need to go back and figure out how to rewrite cosine of y in terms of x. So we go back to the meaning. So for some right triangle in standard position, meaning the positive x-axis out here and then 0, 0 there, what is this input? Well, this is inverse sine, so the ratio is actually x. X doesn't feel like a ratio. Let's think of that as x over 1. And then what's the angle? The angle is called y. Okay? And you can actually see that in the second line maybe, or third line a little bit better. Right here it says sine of the angle y gives you the ratio x, or x over 1. And sine is the ratio of the opposite side to the hypotenuse. So the opposite side is x, and the hypotenuse is 1. Let's check to make sure that's right. What would you get if you took sine of the angle y? You would get the length x divided by 1. No, that works. Sine of y is x over 1. Okay. Now, you don't actually have to use x over 1. You just have to use something that simplifies to x. You could use 2x over 2, 5x over 5, but let's use the easy one. Okay, so if we're going to rewrite y prime, we need to take cosine of this angle y. How the heck do we do that? Cosine of an angle is the length of the side adjacent, which apparently is missing, divided by the length of the hypotenuse. Okay, I got that. The length of the hypotenuse is 1. So how do we get that missing side length? The Pythagorean theorem. And the Pythagorean theorem says, well, the one leg squared plus the other leg squared is 1. And so the missing leg is going to be the hypotenuse squared minus the other leg squared inside a square root. All right. And so what would cosine of y be? Cosine of y would be this. Yeah, highlighted by the bell. If you were paying attention, that was less than 5 minutes or 6 minutes because I paused the video to talk to a student. Okay. Cosine of y is this adjacent side, square root of 1 minus x squared, divided by the hypotenuse 1. We're going to ignore dividing by 1. We know how that works. So we can just replace cosine of y with the square root of 1 minus x squared. So the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. It's really imperative you know how to find these derivatives the long way. This is the sort of thing you're going to forget. You'll see what I mean once we get through the other examples. Next is the derivative of inverse cosine of x. So let's review. What is x? What is y? Well, since we're talking about an inverse trigonometric function, the x is a ratio of sides. The length of the side adjacent to our angle divided by the hypotenuse, which means y is the angle. And if you don't like that, let's take cosine of both sides and have cosine of y is equal to cosine of inverse cosine of x, which means cosine of y is equal to x. Again, we don't have to worry about domain restriction here because inverse cosine only has a domain from -1 to 1. Okay, do you like that part? So cosine of the angle y gives you the ratio of x. Maybe we'll draw our triangle now, but we don't need it yet. So always draw your triangle in standard position, positive x-axis out here, a right angle, and origin down here. So what goes in our angle? We're going to call that angle y. Okay? And if you took cosine of y, you would get x, which means this side is x and this side is, this hypotenuse is 1. What's cosine of y? It's x over 1. Nailed it. Okay. So now we use implicit differentiation. The derivative of cosine of something is negative sine of that something. Our something is y, some function. In fact, this function up top. Okay? So we derive implicitly, we say, well, that'd be sine of y times the derivative of y. What's the derivative of x? With respect to x, just 1. So y prime is 1 over negative sine of y. Just like when we did the derivative of inverse sine of x, we don't want to leave this in terms of y if possible. Can you find sine of y? Yeah, that's what this triangle's for. So sine of y is going to be the length of this side opposite the angle y, divided by the hypotenuse. The hypotenuse is 1, so we just need the missing side length. How do we get that? Well, x squared plus this side squared is going to be 1, so this side is the square root of 1 minus x squared. So the derivative of inverse cosine of x, I'm going to move the negative 1 to the numerator, or the negative to the numerator. Sine of y is the square root of 1 minus x squared over 1, so just negative 1 over the square root of 1 minus x squared. Well, you can stop the video now if you want. You have all the tools you need, but I'll run through the other 4 inverse trigonometric derivatives if you want. So first, we're going to take tangent of both sides, and we'll end up with tangent of y equal to x. I'm going to skip the line where we write tangent of y is equal to tangent of inverse tangent of x. The derivative of tangent is secant squared, okay, of whatever the input is. Our input is some function y, which has a derivative y prime. The derivative of x is 1. So y prime is 1 over secant squared y. Let's draw our triangle. And what is the angle? The angle is called y. And if you took tangent of y, you would get x. So the opposite side divided by the adjacent side to the angle y would be x, so x over 1 fits the bill. Oh no, we have to do secant squared of y, and you folks probably like cosine rather than secant. Well, cosine is going to be the length of the side adjacent to the angle y, 1, divided by the hypotenuse, which means secant is going to be the length of the hypotenuse divided by the adjacent side. Either way, we need the length of the hypotenuse. So that's going to be 1 leg squared plus the other leg squared is the hypotenuse squared. We want the hypotenuse. So 1 plus x squared or x squared plus 1. Your call. Inside the square root, don't forget that. So y prime, we know the numerator will be 1. Let's see, secant of y is going to be the hypotenuse over the adjacent side, so we can ignore the 1, and we're squaring secant, so we just get 1 over 1 plus x squared as the derivative of inverse tangent. Do you see why I said you're going to have to know this process? These derivatives all have 1s and x squareds and fractions and stuff like that. So when you're freaking out on a calculus test, and you know, well, if I need to take the derivative of inverse tangent, I'll just take tangent of both sides, use implicit differentiation, and then draw a triangle to figure out my missing side lengths, you'll be good to go. The derivative of inverse secant, we end up with secant of y is equal to x. The derivative of secant is secant tangent, both of y. And don't forget to chain rule multiply by that y prime. And x is equal. X has a derivative of 1. So y prime is 1 over secant y tangent y. All right, triangle time. let's see. We have an angle named y. If we took secant of y, we would get x, which means the hypotenuse we can think of as x, and the adjacent side we can think of as 1. No. So secant of y is actually pretty easy. Because we were asked for secant of y, and look up top, we have secant of y. That's x. Okay. Actually, not really, but we'll come to that. And then tangent of y is going to be the length of the side opposite y, that's over here, divided by the length of, the side adjacent, that's 1. So we just need this side opposite, which hopefully you're getting good at. Doing in your head is going to be the square root of x squared minus 1. Okay, now, I'm not going to show you why in this video because it's pretty long, but because of the domain restriction for the inverse secant of x, we need to make that a function. The x in this denominator has an absolute value around it. I will show you that in another video. Okay, we are getting close. Cosecant of y is equal to x if y is equal to the inverse cosecant of x. The derivative of cosecant is negative cosecant cotangent. And the input to those functions is some other function y, so we're applying the chain rule, multiplying by y prime. You could also say we use implicit differentiation. The derivative of x is still 1. Hopefully there feels like a pattern that you've got. So y prime is, I'm just going to put the negative in the numerator, negative 1 over cosecant y cotangent y. And, cosecant of y is x. That'll be an easy substitution, but I do need my triangle. I'm not confident. Our angle is y. We're taking cosecant of y and getting x. Cosecant is the reciprocal of sine, or reciprocal function for sine. And so that means x is the hypotenuse and 1 is the side opposite the angle y. If we're taking cotangent, we need this missing side, which is the square root of x squared minus 1. So y prime is negative 1 over cosecant of y, which is x, and multiplied by cotangent of y, which is the length of the side adjacent to y, divided by the length of the side opposite y. Okay, so we're done except for the super weird absolute value. I promise I'll explain it, just not here. Trust me for now. Last one. Cotangent of y must be equal to x if y is inverse cotangent of x. The derivative of cotangent is negative cosecant squared, in this case of y, implicitly defined. So we'll multiply, nope, not dy dx, by y prime, and the derivative of x is 1. Y prime is negative 1 over cosecant squared y. Did you find the pattern yet? If you look back, you're going to find a pattern. I'll try to help you out there in a second. Cotangent of the angle y gives me x, so the length of the side adjacent to our angle is x, and the length of the side opposite is 1. The hypotenuse has a length of 1 plus x squared inside a square root. Let's see. What's cosecant? Cosecant is the reciprocal of sine, so the length of the hypotenuse divided by the length of the side opposite y. Oh, and we are squaring. So negative 1 over the square root of 1 plus x squared is 1 plus x squared in the denominator. Do you need absolute value there? You do not. 1 plus x squared is always greater than 0. Okay? So let's see if you can find the pattern between the derivative of, you should start looking at the derivative of inverse tangent and inverse cotangent first. Then see if you can mix and match the other derivatives of the other inverse trigonometric functions.